There are many Earth-like planets in the galaxy. We live on a world of which 71% of the surface consists of water, and yet we do not live on a water world because even that is too little to be called a full-fledged water planet. This is good news, because just like with vitamins, you never want too much or too little. Right in between is perfect. Water is not that rare in the Milky Way, and apparently there are many worlds that have the same thing. To understand how this is possible, we first must go back to the beginning of our own solar system. The Sun was born from a nebula. How cute! The Sun was surrounded by building blocks that would eventually form our solar system. It turns out that these building blocks contain more water than previously assumed. The problem is that a lot of that water disappeared because of old enemies, radioactive elements. What do those elements do in general? In short, within hundreds of thousands of years they decay. This releases a huge amount of heat. Water tends to flee from large amounts of heat through evaporation. This probably happened to the water in those building blocks. But where did those radioactive elements come from? Nuclear weapons had not been invented yet. Humans neither because, well, no Earth. And they did not come from a nebula. The Sun was born from either. Scientists discovered something unexpected. A nearby supernova must have caused the radioactivity. A supernova is an explosion that occurs when a star dies. Gravity compresses the star inward at 25% of the speed of light, but matter fights back. So much energy is released that the explosion can be seen from another galaxy. But here we run into a problem. Our solar system consists of a disk in which planets orbit. That disk should have been destroyed if a supernova came that close. So researchers in Tokyo came up with a different solution. When a supernova occurred, it produced an enormous shock wave that traveled millions of kilometers toward us. When that shock wave finally reached our system, two things happened. Radioactive elements traveled along with it and hit our disk, but normal elements also became radioactive. The supernova would have been 3.26 light-years away, just close enough to cause radioactivity, but far enough to keep the disk intact. But then the question is, how often did this happen? The researchers discovered something remarkable. There are many medium-sized yellow dwarf stars like our Sun in the Milky Way that are born in the same stellar nursery. It turns out that most of these stars must have experienced at least one supernova at roughly the same distance as ours. If this is true, then 10 to 50% of these stars would have received radioactive elements. But again, why is radioactivity such good news? Because radioactivity causes water to evaporate, allowing rocky planets like Earth to form with the perfect amount of water. But why is too much water a problem? Well, if planets that never received radioactive material end up in the habitable zone, they would become water worlds. Shockingly, tens of percent of the planet's mass would consist of water. There is that much water out there beyond Earth. Life could still arise, of course, but it would likely be far less complex than life here. For a long time, Earth was assumed to be a water planet, until planets like TOI 1452b were discovered, which also lies in the habitable zone. The mass of this planet consists of no less than 30% water. In comparison, Earth consists of only 1% water. You can almost call Earth dry. Could it be that this planet never received radioactive elements? Can you imagine diving into an ocean 20, 50, or even 100 kilometers deep? Yeah, exactly. But would you find anything down there? Life needs the right cocktail, and that cocktail is complicated. But why exactly? Let's make that cocktail. The first ingredient, a normal, stable temperature. The particles that make life possible are easily damaged. So, do you need a perfect temperature? Yes, actually. But more importantly, temperature should not fluctuate too much, because they really don't like that. We throw in water, nitrogen, carbon, and silicon for chemical processes. Now we still need energy from a star. You don't want bacteria getting a winter depression, right? And as the cherry on top, we need protection from an ozone layer, otherwise you burn almost instantly. So is water not important then? It is extremely important for life. But as you can see, much more is needed than just water. Still, we can make our search easier by looking for water first. This research could therefore accelerate our search for Earth-like planets, and with that, our search for life. Researchers did run into many problems with this theory, though. What kind of star exploded? How massive was it? And how fast did those cosmic particles travel? Unfortunately, we don't know that yet. The Earth-like planets we already know will be studied closely because maybe they share the same origin as we do. There is one planet that resembles Earth very closely, Kepler 452b. Until this discovery, we didn't really have a planet we could call Earth's cousin. Like the water world, it lies in the habitable zone, but it appears to contain significantly less water. At least, that's what we think. In an unexpected discovery, scientists found that its year is almost the same as Earth's, 384 days. So how is it possible that one Earth-like planet is completely covered in water, while another might have about the same amount as Earth? Radioactivity could be the answer. Did the largest cosmic explosions make life on Earth possible? That's hard to say, but what is remarkable is that radioactivity, despite all its risks, probably ensured that Earth ended up with the perfect amount of water. And with that, you, the one watching this YouTube video right now, exist. Congratulations, I guess. Thank you so much for watching. This is a new YouTube channel, and I appreciate every like and subscription because it helps growing the channel. Subscribe for new content and new discoveries of the cosmos. See you next time.